Hello everyone, welcome to Minimax Solutions. We were explaining the example questions of chapter 6. So this is example 3. So in this figure, for rays we can see that is OQ, OP, OR and OS are the 4 rays marked in this figure. And we need to prove that angle POQ, angle QOR and angle SOR and angle POS makes the angle 360 degrees. We need to prove. Okay. So in order to prove that equation, we need to do a construction in this figure. Okay, we just extend the ray OQ to the opposite direction. Okay, when you extend the ray OQ, you can see OQ here. So this is ray OQ. When I extend this OQ to the left side, we get a straight line. So this is the construction which I am marking here. Okay, I'm doing it here and I name it as OT. Okay, so I just made a construction which is OT. Okay, I just extended the ray OQ. Now, on the top of the line OT, okay, there forms two angles POT and angle POQ. Okay, what is the property related to that POT and POQ? Now you have already clear about that idea. Okay, two angles are marked here. So we can call them as, those two angles are linear pair angles. Linear pair angles. Why? Because when we combine that two angles together, there forms a straight line. Straight line QT is formed over there, so we can call it as a linear pair. What is the property of linear pair angles? When we add them together, we can get 180 degree. Okay, I'm just writing the angles. Angle POT, angle POT plus angle POQ, angle POT plus POQ, which is equal to now 180 degree, 180 degrees. Okay. Now we need to prove angle POQ plus angle QOR plus SOR plus POS equals 360 degrees. So we have to consider the angles, which is the downward direction of this OT as well. Okay, these angles also we need to consider. We consider the upward angles, which are POT and POQ. Now we consider the downward angles, which are TOS, SOR and ROQ. We have to consider these three angles as well. At first, okay, I'm just considering the given angle without the constructed angle, angle SOQ, which is given in the figure, already given in the figure. Angle SOQ. Angle SOQ is a combination of two angles, right? In SOQ, we can find two adjacent angles. Which are the two adjacent angles? Angle SOR plus angle ROQ. These are the two adjacent angles formed inside the SOQ. Okay, SOQ is formed by combining these two angles. Clear? Now, which is the linear pair of angle SOQ? Which is the linear pair of angle SOQ? Linear pair of angle SOQ. Which means which angle will be added to SOQ in order to get 180 or a straight line angle. So which angle I need to add with SOQ? Which angle I need to add? SOQ plus, yes, SOT, angle SOT, we will get 180 degrees. Clear? So angle SOQ plus angle SOT will make 180 degrees. Already we have one equation here, equation number 1, and here we got SOQ plus SOT equals 180, that is equation number 2. Okay, and add these two equations together. So when you add these two equations, angle POT plus angle POQ. When you add 1 and 2, the left side of equation 1 I just wrote. Now it is to be added with the left side of equation 2, that is angle SOQ plus angle SOT, which is equal to, I just added the left sides of equation 1 and equation 2. What I did here, equation 1 plus equation 2 I just did. Here the LHS are added. Now I have to add the right side of RHS of this equations, which is 180 plus 180, which is equal to 360 degrees. Okay, now we have to compare this one with the given, or in order to prove what we need to prove in the question. What is asked to prove in the question? What is asked here? POQ. Angle, first angle is angle POQ. So that angle is given as such. We have angle POQ here. See, we have angle POQ. Angle QOR. Is that here? Angle QOR. QOR, which is not marked here. QOR is not marked. Okay, and angle SOR, that is also not marked here, but we can see that angle SOR is this angle and angle QOR is this angle. When you combine that two, we get another angle. What is that? That is angle SOQ. SOQ can be split up with those two angles. Which are the angles given in the question? QOR and SOR. QOR and SOR, that combines to form angle SOQ. So SOQ, this condition I can write as equation 3. From equation 3, I can split this SOQ as SOR and ROQ. ROQ is same as QOR. Both the ways we can write. Clear? Now what? Angle POS. That is also not marked here. Angle POS. That also we need. Okay. So from 3, okay, using 3. Okay. Using 3, I can write angle POT. Let be there. Angle POQ. Angle POQ plus I'm splitting this SOQ. Splitting SOQ as angle SOR plus angle ROQ I just wrote here. Okay, ROQ. Okay, in the question instead of ROQ it is given as QOR. You know that both the angles are equal. Okay, because the center point is the same. Okay, the arms are the same, so the angle ROQ and QOR are the same thing. So I can write here as QOR. Okay, plus SOT, which is equal to 360 degrees. Okay, now for the equation we need to prove we have 3 angles already. We got the 3 angles. One more angle left. What is that? Angle POS, which is left. POS. So from the figure, when you check the figure, POS also has 2 angles in it. One is POT, another one is SOT. POT, see here, we have POT here. And SOT. Where is SOT? SOT is also here. Clear. So when you combine POT and SOT, POT and SOT, you check the figure. POT is this angle and SOT is this angle. When you combine that two angles, which is the total entire angle you are getting? POS. We are getting POS. Okay, so I am combining this POT and SOT. Then I am writing angle POS plus angle POQ plus angle SOR plus angle QOR. This SOT already it is taken, so we don't need to use it anymore. So it is 360 degree, which is equal to 360 degree. So this is the thing we need to prove in example 3. Hope you understood this. Okay, any part, any confusion in any step, you can ask me as the comment, and we can just continue with the next examples and exercise questions in the next videos.